So, transformations of functions. So, some of the basic ones that we would start off with would be y equals, or f of x equals x squared. That would be a parabola going through 0, 0. So u-shaped. How about absolute value of x? So that would be like a v, also going through 0, 0. Square root of x. So starting at 0, 0, it's like half of a sideways parabola. So starting at 0, 0, increasing kind of quickly and then slowly. And then how about x cubed? So that looks like a, I don't know, kind of like S-shaped. And then how about cube root of x? So this would be just the x cubed turned around. So I think is that just reflected over the origin maybe? So these are kind of some of the basic graphs we start with, some of the more common ones. There's more, but these are the most common. And then we can move them based on what happens to, let's say for what we're squaring, if it's a number being added or multiplied, it's going to move the graph around and do different things to it. So let's talk about that now. So let's do our vertical shifts first. Vertical shifts. So this happens if I have a number outside of the function. So either plus b or minus b. So this means that the function is shifted to the up b. Okay, so this is f of x moved up b. This one is f of x moved down b. Okay, so if we hit add, because whatever's happening, we add a certain value, the y value, it's just going to go up, subtract, go down. And we'll see this with some examples in a minute. Horizontal has to do with if it's a number on the inside of the function, a f of x plus b or f of x minus b. So this would be f of x moved. Now here, like I said, this is going to be the horizontal shift, so plus b, you would think, kind of our tendency is to think, okay, that's to the right, but it's actually flipped around the opposite. We move to the left b if it's a plus on the inside. Minus on the inside you would think is left, but it's actually, we're going to move to the right. Right b. Okay, so that's up and down, right and left. Now how about reflections? Reflections. So if we have f of, I'll put the one on the outside first, negative f of x, or f of negative x. So we have a negative sign on the outside or the inside. So if it's on the outside, then the graph, original graph, f of x, is reflected across the x-axis. And if there's a negative on the inside, it's f of x is reflected across the y-axis. And then last, if we have stretching and shrinking. Okay, so this is going to be if we have a number in front of the function or within the function. And generally speaking, this, whether it's outside, inside, could have an effect of if it's getting stretched or shrunk, and obviously depending on the the original function, that could have a little bit of an effect. But generally speaking, if you have a's greater than 1 versus less than 1, so if you have a is greater than 1, typically that means it's being stretched or made steeper. Actually, I take that back. Let's just say steeper. And then if it's less than 1, it's wider. I guess it depends on which way you think of it being stretched or shrunk. Okay, because if it's steeper, something like an x squared, you could think of it like it's stretched up vertically, but that it becomes steeper. If it's something like 2x squared, it's going to jump up quicker. Versus if it's a half x squared, then it's going to be wider. So the closer that a gets to be 0, it's going to become wider and wider and wider, stretched horizontally. Okay, so now, order of transformations. So it's like the order of operations of doing transformations. So first we have to do our right and our left, or horizontal. Let's just say horizontal. So first we do our horizontal, then we do our stretching, shrinking, making it wider or steeper. Then we do our reflection. And then last, we do our up and down. So it's important to follow this order of doing all of these transformations in order for it to come out correctly. Okay, so let's do one all together now. Oh, a bunch of these things happening. So, for our first one, let's do f of x equals negative cube root of x plus 5 minus 2. Okay. And I think what I do is I kind of know all the things going on, what they mean. So this minus in front, the negative in front, this means it's going to be reflected over the x-axis. This plus 5 means I'm going to go left 5. Because remember, it's right or left if it's on the inside. So notice this is on the inside of the cube root. You would think it's to the right, but actually it's to the left. And then the minus 2 is down 2. So that the 2 is on the outside, so that means up or down. Minus means down. Okay, so in my order, 1, 2, 3. So I didn't have any stretching or shrinking, so I could skip that one, jump to reflecting and vertical. So first of all, let's kind of sketch my general one. Cube root of x. So cube root of x looks like this. So next, when I do my left 5, so now, and just use like 0, 0 as like your starting point. So now my starting point is at negative 5, 0, but then it's still going to have the same shape. Okay, so then I'm going to reflect across the x-axis. So that means this is going to get flipped around, flipped on the x-axis. So around the x-axis. So I'm going to flip around this way. Okay, so now I'm still at negative 5, 0, but now instead of going to the right of that point going up, it's going to be going down. And for the less than negative 5, instead of it being below, now it's above the x-axis. And then last, down 2. So go down 2. So now my starting point is at negative 5, negative 2. But then I still have this shape for my last one. So it's going to go down this way, up this way. Okay. Now, it's usually a good idea to check out a couple points, see if they make sense. Let's check out a couple of these x's. Well, usually plugging in 0 might be easy. Actually, in this case, though, it might not. I'm looking at what's going to be an easy cube root. Well, 8. So if I plug in x is 3, let's see these two. 3 plus 5, so I'd have the negative cube root of 8 minus 2. Cube root of 8 is 2, negative 2 minus 2 is a negative 4. So see if that makes sense. 1, 2, 3, go down 1, 2, 3, 4. That looks about right. 3, negative 4. How about f of x equals negative 2, absolute value of negative x minus 2 plus 1. Okay, this one's got a lot going on, lots of negatives. So, I've got a number in front of the absolute value. So, let's kind of just look at this one at a time and all these different things going on. So this negative means that I'm reflecting across the x-axis on the outside. The one on the inside means I'm going to reflect across the y-axis. This 2 in front, this means I'm going to be, basically all my y values are going to be doubled, so this is going to be steeper. Minus 2 here, that's going to be to the right 2. And then this one's going to be up 1. Okay, let's put some order to this. 1, 2, both of these are 3, step 4. So we've got every different type of transformation going on with this one. Okay, so first of all, regular absolute value is a v. Next, so step 1, going to the right 2. To the right 2 looks like this. Now steeper. Okay, so every y value is going to get doubled here. Now instead of at 1, it being at 1, it's going to be 1, 2. And then up to 4. So all the y values are going to get doubled. So it'll be steeper. So now how about my reflections? Okay, so over the, and doesn't really matter the order here, over the x is going to be down like this. And then across the y, so that's down this way, now across the y means that now I'm going to be at negative 2 and going down from there. Let's write it a little better right here. So at negative 2, 0. And then, you know, up here it was y-intercept as a 4. Now it should be negative 4 with that steepness and reflected. Okay, and then last, up 1. So up 1. So now I'm at, negative 2, 1. Negative 2, 1. Okay, and even if I wanted to get it pretty exact, if we think about my negative 4, well, it moved up 1 as well, so that's negative 3. Again, I can plug in a couple points to check it out. Do a couple real quick. Like how about negative 1? So if I plug in negative 1, negative 1, I have to go up here to leave some room. Negative 1 would be positive 1, minus 2 is negative 1. That'll turn into positive, negative 2 plus 1 is negative 1. So does that seem about right? Negative 1, y would be negative 1. So I'm going to draw it quite steep enough. Right there. But that looks about right. Let's try like somewhere over here. How about negative 6? It looks like it should be something pretty low. So negative 2, when I plug in negative 6, I become positive 6 minus 2 is 4. So negative 8 plus 1 is negative 7. Yep, that looks about right. Down 7. Okay, so it's a good check. Pick a few points. Make sure you got everything.